Welcome back everyone to part 3 of text generation with Python and Keras. In step 3, we're going to focus on creating batches. That is to say, we understand the way the text sequences are organized and shifted one character forward, and then we'll actually use TensorFlow's built-in datasets class object to generate those batches and shuffle those batches for us. Let's head back to the notebook where we left off last time to check this all out. Alright, here I am at the notebook where we left off last time. Previously, we discovered how we could take our raw string data and encode it so that every character has a unique integer assigned to it. Next, what we need to do is actually create our training sequences. Those are the batches we're going to be training our model on. Now, the next thing before we actually create those sequences, though, is to figure out how long should these sequences be. Recall that our model is a character-based model. So, for example, if I were to grab a portion of the text, let's grab the first 500 characters and print that out. Here we can see the general structure, in this case, of a sonnet. So let's go ahead and just grab a line from this. So I'll grab the first line, and let's say line is equal to, and we'll just put in that single line. So how long is one line of text? So it looks like one line of text is 41 characters. What we want to do is make sure our training sequences are long enough that they'll actually be able to pick up the general structure of the text. And luckily, Shakespeare has a very specific structure due to its iambic pentameter. As you can see here, things tend to rhyme every other line. Not exactly, but more or less. So we have increase with decease, die and memory, fuel and cruel, eyes and lies, etc. So we should probably have at least 3 lines in order to try to understand that structure. So that should be around, if we check out the copy paste here, we can see lines, and let's go ahead and put this in using triple quotes here because it's multi-line. Let's check the length of those lines, and it looks like about 133. So if on average each line is around 40 characters and 3 lines is 133 characters, probably let's go ahead and choose our sequence length of 120 characters. Kind of a smaller set of 3 lines. Keep in mind, your actual character sequences will depend on the actual structure of your text data and what you're trying to achieve structure-wise with your character or current neural network. But in our case, 120 characters seems to have enough information to actually capture everything, but not so much that it's going to take a really long training time. So we're going to choose sequence length of 120. And then what we're going to do here is calculate the total number of sequences in our text. So for this, we can say the total number of sequences inside of the text is merely the length of that text, the full text, and then we're going to use 2 forward slashes here so that it's classic division instead of true division, essentially rounding this off. And then we'll say sequence length plus 1 because of 0 indexing here. Go ahead and run that, and we should see that we have about 45,000 sequences total. So let's go ahead and create the training sequences, and we can do this with the special dataset object from TensorFlow. So I will say character dataset is equal to, and we say tf.data.dataset, and then we're going to be constructing this from tensor slices on our encoded text, not on the original text. Okay, so go ahead and run that. May take a little bit of time depending on your computer, but if you check out the type of character set, essentially this is a special tensor slice dataset. And with that, if we check out character dataset and then do .tab, you'll see that it has a bunch of method calls off of it. So one of them that's the most convenient we're going to be using is this batch call. So the batch method converts these individual character calls into sequences we can feed in as a batch. So let me show you what that actually looks like. We'll say for item in character dataset, and then we'll call this take method, and this take method basically just creates a dataset with at most count elements from this dataset. So we'll say 500, and then we'll go ahead and print those items, but those items, in order to be printed, need to be converted to NumPy. So if we just print out these items, you'll notice it's essentially the encoded text, which means I could say index to character and pass that in, to that array. And then you'll notice as you scroll down, it's essentially character by character being printed out from various creatures, we desire, etc. So that's what's actually inside of that large character data set. So what we can do now is create sequences from it. So I can say sequences is equal to that character data set. And then I'm going to call this batch method. And this batch method combines consecutive elements of this data set into batches that we can then feed into our neural network later on. So we're going to define the first item as sequence length plus 1. And we're using plus 1 because of 0 indexing here. And then we also say drop remainder is equal to true. So as you probably suspected, recall that our total number of sequences, if we actually divide it out with classic division, is 45,005. But if we were to do this with true division and run that, you'll notice that it's actually not a perfect fit, which means the actual number of characters in our entire data set is not perfectly divisible by our sequence length of 120, which makes sense. You wouldn't expect it to be perfectly divisible by 120. So that means you're going to have some remainder characters at the very end. So what we do here is we say drop remainder is equal to true, so it just discards those last couple of characters. And in our case, it's not a big deal to discard that because it's going to be either 119 or 119 characters or less out of a character set of more than 5 million characters. So dropping those last 119 or less is not a big deal. So we'll go ahead and run this. And now we have our sequences. So now that we have our sequences, we'll perform the following steps for each one of those to create our target text sequence. We're first going to grab the input text sequence, assign the target text sequence as the input text sequence shifted by one step forward, and then group them together as a tuple. To do this easily, I'll just create a function. We will say df create sequence targets. And so given a particular sequence, essentially a sequence of 120 characters, we're going to say the input text is equal to sequence starting from the beginning all the way up to, but not including that last character. So that's :-1, which means our target text is then equal to the sequence shifted one forward. So starting at index 1 instead of index 0, go all the way to the end. And then we'll return input text target text. So what this is doing is you can imagine that this is going to grab something like hello, my name without the E, and this one is going to be ELO, my name. So this is starting from all the way to the beginning, go all the way up to, but not including that last character. Keep in mind this would be 120 characters. And then this one, starting at index 1, go all the way to the end. So essentially we get the same sequence shifted over by one time step, or one character step into the future. So you run that, and then we're going to map that to all the sequences, so that my final data set is sequences.map, and we'll say create sequence targets. Go ahead and run that, and then what we're going to do is just show you an example of what this actually looks like. So I'm going to say for input text, comma, target text in my data set, we'll just go ahead and take one example of this. We'll do the following. We'll say go ahead and print input text as a NumPy array. And then we'll print the index to character of our input text, NumPy. And let's go ahead and join that. Since that's just going to be a list, we'll say join that. Make sure you check your braces and parentheses there. We'll print a new line for some clarity, and then we'll print target text in terms of NumPy. And then we'll say print, and then we'll go ahead and join that as well. We'll say join, index to character, in this case the target text, NumPy. So this is essentially showing you what the first batch will look like. So the very first batch essentially looks like this. Note it goes 0, 1, 1, 1, etc., all the way to 76, 75. That's the first sequence. This is what it actually looks like if you were to see it as characters. Keep in mind our network is going to see the numbers, not these actual characters. And then the next batch, notice it starts at 1. So here we see 0, 1. This one's going to 1. And then it goes 76, 75, but this one extends to 76, 75, and 1, where 1 is essentially just white space. So you can see here the string as well. So even though the strings, when they're printed out, look actually similar, this one has extra white space. And you can kind of tell by the fact that I'm highlighting it. The highlighting ends at T, but here it ends at the white space. You can confirm that by saying we have that extra 1. So this is the target, this is the input sequence, and then this is the second one's the target sequence. Okay, so let's go ahead and now show you how to actually generate those training batches. So now that we have the actual sequences, we can create those training batches. Just choose a batch size. Let's go ahead and choose 128. And then we want to make sure we shuffle these so the model doesn't learn on a particular ordering of the text. It should be able to take any random snippet of text and start generating the next sequence from it. So to do that, we'll say dataset is equal to dataset shuffle. And just to make sure everything's not shuffled in memory, we're going to only take batches at a time to shuffle. So we'll say buffer size is equal to 10,000. So essentially what this means is just take in 10,000 of those elements and then shuffle them around. Because if you don't actually specify a buffer size, when you call shuffle, it'll attempt to read in the entire data set in memory and shuffle that. And if we're dealing with a really large data set, that could cause error. So we just say dataset.shuffle buffer size, and that will help out with any memory potential issues. And then the batch, we pass in the batch size, and then again we say drop remainder equal to true. Okay. Go ahead and run that, and now we should have our data set ready to go. Notice the shapes, it's 128 by 120, so 128 different types of sequences where each sequence is 120 long. And then we have this tuple where we have the input sequence and then the target sequence. Okay, this is probably one of the most complicated steps out of this entire process, but if you understand the main idea that your batches essentially look like this, where you have one sequence of encoded numbers that relates to an original string, and then the target is that sequence shifted over by one number, again relating to some string, then you essentially understand the actual process. The technical parts of creating this with this dataset object, that's probably the most complicated part, but if you understand the fundamental idea of this encoded sequence being shifted one time step forward, then you pretty much got this section down. Note here that this 128, that refers to the batch size. So we're going to be feeding in 128 of these sequences at a time, where each sequence is 120 characters long. So we have the input sequences and then the target sequences. Coming up next, we'll focus on creating the actual model. Thanks, and I'll see you there.